I'm going to try to talk a bit more as opposed to actually work from the verbiage on the slide. So, you know, I listened to the previous two presentations, and, you know, I think from a General Motors standpoint, we approached our strategic sourcing process very similar to what was described at John Deere. We use we use what we call total enterprise cost, and I mean it takes into account all of the things that were indicated in the previous two presentations. And when I was thinking about what to pull together, I didn't want to spend a ton of time going through that decision-making process, because I think you know, as a large global company, General Motors operating around the world on almost every continent. We haven't quite decided to manufacture in Antarctica yet, but you know, we have to take all of these risk factors, and one of the pieces that didn't come up is transportation, which you're going to see in the example that I'm going to go through, was one of the decision points. So what I wanted to do today is spend a little bit of time not talking about the company. I wanted to talk about the Chevrolet Volt, which is a vehicle that hopefully you've heard of, give you a little bit of information surrounding the Volt, and then spend a little bit of time talking about the energy storage system, or the battery, or battery pack that's in the vehicle, and then some of the decision criteria that we utilize when we work with a partner to change the manufacturing strategy surrounding that particular product. So just quickly, you know, what is the Chevrolet Volt? I mean, it's fundamentally it's an electric vehicle, but the unique part of the Chevrolet Volt is we have not only a purely electric energy source, being the battery pack. We also have a range extender, is what we call it. Essentially, it's a gasoline generator, and what this does for the vehicle is that it extends its range from a single tank of fuel. You get a total of about 300 miles worth of range. Purely electric, you'll get about 40 miles worth of usable range. And what's unique about that is right now, when you take a look at electric vehicles in the market, there's this term that's thrown around called range anxiety. And you know, if you've got a vehicle that's got batteries, you can go 100 miles. You know, if you're 20 miles away from home range, it's not a real comfortable feeling. So, you know, we recognize that. I mean, obviously, here in the U.S., we're also launching in Europe, but you know, the U.S. consumer, we like to have a bit more freedom. So what this vehicle does is 80% of the population would be able to, in their daily commute, would be able to drive gasoline free. I mean, we'd be able to go to and from work, get back home, and be able to do that all without using a drop of gasoline to propel the vehicle. So that's what's unique about the vehicle. When you look at it from my perspective, if I step out of the company as a consumer, probably the most unique or most interesting aspect of the vehicle is when you get in it, it feels like a normal car. It doesn't feel like a science experiment. It doesn't feel like it was something that was just thrown together. It feels like a normal car. It drives like a normal vehicle, and it's got a host of technology, touchscreens, etc., on the interior. So it's a nice vehicle, and if you haven't had a chance to see one, I hope you take that opportunity. So, you know, so when we took on this task of designing the Volt, we had to build off of what we learned from the EV1. I mean, this was an electric vehicle, our first attempt back in the 90s. I'm sure people have probably seen Who Killed the Electric Vehicle. But we built off of that vehicle. We built off of our knowledge of that particular vehicle, and we were able to reduce the mass of the battery pack, which is extremely important. And obviously, when we took on that task, we had to find the proper partner. And what I'm trying to do is walk you through the vehicle, and then you'll see from the supply chain perspective how it becomes very, very relevant. So the lithium-ion battery pack, it's got about 10 kilowatts worth of usable energy, over 200 individual cells, and I could go on as an engineer, but let's just say it's complex. It's extremely important that it operates. It's also it's a device that you plug in at your home that you would charge off of a normal outlet. We do also have a 200, 240 charge unit that you can also put in your home to shorten the charge period. But what that also then does is there's safety, there's UL ratings, etc., that all come into play. So again, when looking for a partner to develop this type of a product, cost is important, but it is definitely an opportunity when the overall cost of ownership, enterprise cost, whatever the term is you like to use, has got to be factored into that decision, because saving a couple dollars up front could be extremely expensive on the back end of that decision. So this is a high resolution image of the battery pack, and you know the interesting thing here is it's full of lithium-ion cells, similar to what's in your laptop or in your cell phone. All of us are used to the 18-month lifespan, etc., that you get there. Again, we're putting this in vehicles. There's a different expectation that we've got to support from a customer standpoint. So we are warranting this product for 10 years. So again, ensuring that this is done right for the first time is extremely important, and what we look at when looking for a partner in this space. So we developed the battery pack in-house, and given the scale and the magnitude of what we were trying to do, we leveraged, again, the knowledge that we had utilized in the past. We had made our manufacturing decisions from where we were going to assemble the battery pack, where we were going to assemble the vehicle here in the U.S. But again, a pack of this size, weighing as much as it does, we looked at multiple companies, and we didn't do perhaps your normal sourcing process where you send out your requirements and you kind of consensus on what the product is going to be, and then you go into a negotiation cycle. This is one where this had never been done before. So there was creation that was going to be required. So we went through almost a year-long process of working in parallel with multiple companies and evaluated those solutions to pick what ended up being an industry-changing product. So when the decision was made to partner with LG Chem, and LG Chem is part of the LG group. The LG Electronics that does some consumer electronics business also. But what they brought to the table was unique cell chemistry, which provided us with the needed power density to be able to provide the range that was required to satisfy the customer, but the density piece is important, because you can't continue to just add batteries to a vehicle because you continue to add mass, and then it becomes kind of a circular argument at that point, to where you can only go so far with a given technology. On top of that, they brought the strength of the entire LG group to the table, because we're not just talking about a cell or a battery. There's all of the power management, charge management, etc. that's required to do this. So we made the decision to partner with LG for the cells. We made the decision that we were going to assemble the cells into a pack. And the initial plan by LG was to manufacture the cells in Korea. Those cells would then be shipped to our Brownstown battery assembly plant, be assembled in the cells, and then we would ship those battery packs, or I guess energy storage systems, down to Detroit and Transit. So when you look at that supply chain, for initial low volume type of production, one could sustain that. The challenge, though, becomes when you want to take this type of a vehicle into mass production. Trying to manage that supply chain, trying to coordinate moving that number of cells via boat, carrying that type of inventory, that type of cost, dealing with the associated quality risks of having that type of a supply chain, it was not something that we saw as being sustainable over the long term. A bit of insight of what the manufacturing process is for the cells. Again, I was given technical points to go through, but at the end of the day, it's a very complex process, extremely capital intensive. So again, you can't make a manufacturing decision or chase labor rates around the world. You're going to drop this type of capital. The decision needs to be correct. It needs to be made one time, and then you've got to have the intestinal fortitude to continue to drive that as you move forward. So, like this particular vehicle, this is just, again, to give you some insight into the type of money that was spent in Michigan on this particular vehicle. This does not include the investments that were made by LG. So again, coming back to the concept of manufacturing, where you're going to a concept that within General Motors we believe very strongly in. So this vehicle was primarily going to be consumed in the United States, and from a sourcing footprint, this is what makes sense from a strategic standpoint. So with originally, Ocheon, Korea was the manufacturing strategy. And as we looked at the demand for the product, as it continued to grow, as we looked at the needed capital investment that was going to be required to support said volumes, and then on top of that, there was some government subsidy, stimulus money, whatever you want to call it, that also became available. It supported the George to move the future production of this battery cell to Holland, Michigan. So we're in the process of the final steps of executing that. Again, we're talking about close to $100 million worth of investment on behalf of this particular company. But what it will provide us with is the cell itself will be manufactured in Holland, Michigan. It'll be shipped from Holland, Michigan to Brownstown, Michigan to be assembled into a pack. And then that pack will be shipped to Detroit and Transit, which is right outside of Detroit. So the value stream for this particular assembly within the vehicle has been shortened. We've saved close to $500 in logistics costs per pack. Again, given the size and magnitude of what we were trying to move, it was clearly the right decision for the company. So, I mean, the car is great. That's my opinion. But don't take my opinion. There's a lot of other people that say the vehicle is nice. So there is an element of a sales pitch here. If you haven't had a chance to experience the vehicle, I'd ask that you do. Again, we won a significant number of awards for the product, but again, the manufacturing footprint, the manufacturing strategy behind the vehicle, partnership with LG, the extreme level of transparency that both companies gave each other, were critical in making this particular product the success that it has been in the marketplace. So that's what I was sent to deliver. I know that there's probably going to be more questions surrounding our sourcing process, what we use to make these decisions. It's very relevant in my space, responsible for all of the electrical procurement for the company globally. And then also building off, I came in late, I'm also responsible for our supplier diversity program within General Motors, and I saw the tail end of that presentation also. So I thank everyone for their time, I thank you for your attention, and again, I'll be around for any questions.